Hello everybody, this is Rob Swatsky from the York campus of Hack, and welcome back to my Biology 121 Anatomy and Physiology 1 course. This is podcast 2.1b, the structure of atoms. Atoms are the building blocks of matter, and all elements are made of atoms. An atom of an element is an extremely tiny unit of matter that still possesses the properties and characteristics of the element. Think of atoms as the purest form of an element. Each atom contains three subatomic particles called protons, neutrons, and electrons that determine the characteristics of the atom and have important roles in chemical reactions. The nucleus is the central region of an atom which contains the tightly packed protons and neutrons. Electrons are moving at high speeds in a spherical region around the nucleus called the electron cloud. Each proton has a positive charge and is symbolized by a P with a plus sign superscript. Remember the phrase, protons are positive, to help you remember their charge. Each neutron is neutral, which means it does not have a charge. Neutrons are symbolized by an N with a 0 superscript. Remember the phrase, neutrons are neutral, to help you remember their uncharged state. Electrons are the smallest particles, with each containing a negative charge. Electrons are symbolized by an E with a minus sign superscript. All electrons move around the nucleus within the electron cloud, but some groups of electrons move within specific regions of the cloud called electron shells. We can represent electron shells in a diagram of an atom by drawing several concentric circles around the nucleus. Each electron shell can hold only a certain number of electrons. The first electron shell is the one closest to the nucleus and can hold a maximum of 2 electrons. The second electron shell can hold a maximum of 8 electrons. If the atom contains more than 10 electrons, those are placed into a third electron shell that can hold a maximum of 18 electrons. Electrons are always placed into the electron shells in a specific order, beginning with the first electron shell. For example, an atom of phosphorus has a total of 15 electrons. There are 2 electrons in the first shell, 8 electrons in the second shell, and the remaining 5 electrons are in the third shell. The atomic number is the number of protons in the nucleus of an atom. Each element has a different atomic number because each has a different number of protons. Think of each atom's atomic number as its signature. Just like your handwritten signature is unique and identifies you as being you, the atomic number of an atom identifies the element. For example, carbon has an atomic number of 6 because it has 6 protons in its nucleus, and zinc has an atomic number of 30 because it has 30 protons in its nucleus. The net, or overall charge of an atom is 0. This means that the number of positively charged protons must equal the number of negatively charged electrons. The number of positive charges cancels out the number of negative charges, so the net charge is 0. Atoms that have a net charge of 0 are called electrically neutral. For example, potassium has an atomic number of 19, which means it has 19 protons. Because the net charge of one potassium atom must be 0, it must also have 19 electrons. The other important number describing atomic structure is the mass number. The mass number of an atom is equal to the number of protons and neutrons in the nucleus of an atom. Even though electrons have a mass, it is extremely small and negligible, so they contribute nearly nothing to the overall mass of an atom. This is why we don't consider electrons when determining the mass number of an atom. There is a chart that we use in chemistry called the periodic table of elements that lists all of the known chemical elements and arranges them left to right in rows in order of their atomic number. It's an important tool that includes information about atomic structure as well as helps us understand the relationships between different elements. Each of the 7 horizontal rows is called a period, and all elements in a period have the same number of electron shells as their period number. For example, an atom of hydrogen or helium in the first period has 1 electron shell, while an atom of potassium or iron in the 4th period has 4 electron shells. Each vertical column is called a group, and the elements in each group share similar chemical properties. The periodic table is a handy reference tool because it also lists the atomic number and atomic mass of each element. The atomic number is usually written above the element symbol, and the atomic mass is usually written below the symbol. The atomic mass is the average mass of all the naturally occurring isotopes of an element and is measured in units called Daltons or atomic mass units. What are isotopes? Isotopes are atoms of the same element that have a different number of neutrons and therefore a different mass number. Even though all atoms of any given element will always have the same number of protons, they can have different numbers of neutrons. For example, all atoms of nitrogen have 7 protons and 7 electrons. An atom of nitrogen will always have an atomic number of 7. Most nitrogen atoms have 7 neutrons, but some may have 8 neutrons. A nitrogen atom with 7 neutrons has a mass number of 14, 7 protons plus 7 neutrons, while a nitrogen atom with 8 neutrons will have a mass number of 15, 7 protons plus 8 neutrons. Most isotopes are stable, which means that the structure of their nucleus does not change over time. Isotopes are often written with their mass number as a superscript to the upper left of the symbol, such as 14N and 15N, or their mass number is included after a dash following the symbol, such as N-14 and N-15. However, some isotopes are unstable and are called radioactive isotopes or radioisotopes. The nucleus of a radioisotope is in a state of spontaneous decay or change as it moves into a more stable configuration. Some examples of radioisotopes include hydrogen-3, carbon-14, oxygen-15, and iodine-131. As a radioisotope decays, it releases radiation in the form of subatomic particles or energy, and because of this, can transform into a different element. An example is the decay of the radioisotope carbon-14 into nitrogen-14. The amount of time it takes for a radioisotope to decay to half of its original quantity is called its half-life. Depending upon the radioisotope, this can be measured in seconds, minutes, hours, days, years, or even millions of years. Even though radioisotopes can be harmful, some have benefits and are often used during medical imaging procedures in order to diagnose and treat certain disorders. Tracers are radioisotopes that are used to follow the movement of a specific substance through the body. For example, thallium-201 is used to monitor blood flow through the heart during an exercise stress test, and iodine-131 is used to determine the size and activity of the thyroid gland. Thanks for watching, and please feel free to contact me by email at rjswatsk@hack.edu if you have any questions or comments about the course.